So fine. So as we were discussing earlier uh, about the smart buildings, correct? So we discussed the KNX, and also the BACnet one. Okay, right? Yeah. So we spoke about introduction to the KNX technologies and the BACnet, right? In the last previous sessions. Now there was a pending section where I wanted to touch base, and also in if you remembered in the last the class I was showing the Cisco's uh, smart technologies, that is, which is including a Cisco Spaces, right? How we can able to utilize that Cisco Spaces technology, and then we how we can able to adopt the different the product line which the Cisco is providing us for the smart building, right? And also we saw how we can able to utilize the access points, right? Which is 9100 access points in the Cisco, and where we can able to utilize the BLE antennas, right? In the similar way, now let's continue with the session now. So here, so previously we were talking about how the IoT will be connecting via the wired network, correct? Now, so what if like we cannot be able to lay the cable, and we cannot do the cabling connectivity, right? The physical connectivity, how we can able to do that? So in that conditions, what we can able to do is we can able to use leverage the we can able to leverage our wireless technologies. Okay, there are a couple of wireless technologies we will be having, right? So let me open this. Yeah, so here main important the wireless technologies. The number one, it is thread and matter, and the second one is the BLE mesh, and third one is long range, the WAN. Okay, so you might have heard about the BLE mesh, right? It is very much the famous one where we use the BLE technology for the uh, connectivity of the access points, so that the wireless IoT can seamlessly connect with each other, and also they can able to talk to our servers. So that was the one important you know the technology, right? So let's deep dive on these technologies now. Okay. So now coming to the threat and matter, right? So in threat and matter, it is IP version 6 based. Okay. And the main important point here is it will have the low power mesh networking protocol, that is 6LOWPAN. Okay. This is what the technologies this will be using. Okay. And coming to the IEEE reference, it is IEEE 802 154. Okay, this is the reference number for the IEEE standard. Okay, and the second point here, it is in self-healing one. Okay, when I say the self-healing, let's say if, for example, if we are taking a thermostat, okay, thermostat, this is one of the smart IoT device, correct? If we are connecting this within a room, okay, if this get fails, what will happen? So the complete room probably might not be able to adjust the temperature, correct? So how we can able to have design a resilient system. So in this specific threat and matter, what we will be having is we will be having the different IoT devices, that is thermostat within the room, right? So for the redundancy, even though one get fails, so this threat and matter topology, what it will be doing is it will check for other thermostats within the room, and it will send the command which supposed to be sent to the this primary IoT device, and that will be sent to the other IoT device. Okay, that is one thing. So now, even though one fails, the other one will picks up, and the status of the room will remain intact. That is, the room temperature or the air quality will be same as we expected, right? That is one thing. Okay, and the use case, coming to the use case. So whenever we are choosing a threat and matter, right? So it breaks the vendor lock-in. Okay, it is not specific vendor. It is an vendor agnostic one, and so this is specifically like you may choose the different OEM. So I already explained, right, in the various the PPTs. So different OEM have their own products, own the way of designing the system, right? So how do we choose a different product from the different OEM, and how we can able to integrate that with our system? So basically, in that case, we need to choose any of uh, the technologies which allows the different vendor to integrate seamlessly. So this is one of the protocol. Okay. So now coming to the penetration range, what is the range we will be using? So whether it is applicable for the bigger room, smaller, or else campus. So this specific thread and matter topology, it is only for the room level. We cannot implement that to the facility wide. Okay, if there is any small room or conference room or a small building, we can able to utilize, because it will be very small implementation what we can able to implement by using this specific protocol. So that is one thing. So coming to the second, this is most commonly and most important, the topology, that is the mesh, BLE mesh. Okay, in the BLE mesh, so how this will be connecting to the each other? This is very interesting one, right? So let's assume we have the building. Okay, 5 floors of the building, and in that we will be having the different floors. Okay, let's say this is floor number 1, 2, 3, 4, and 5. So think like if you are having the 100 number of IoT devices here and 100 number of IoT device here. If it is in static, then okay, you can able to put the cabling to the 100 number of devices. So if it is in dynamic, so when I say dynamic, what if the IoT device are the moving around in the floor? It will be very much difficult to do the cabling, correct? So that is the main, the use case where we can able to use the Bluetooth technology within the facility, and we are establishing the Bluetooth across the complete building, and this the IoT or else IoT should have the Bluetooth capability, right? Then only it can able to connect to the BLE mesh. Okay, one thing. And second thing, we also can able to utilize the BLE tags. Okay. What are these BLE tags? So these BLE tags are the very small device, the battery operated device. These tags can be installed to the any one of the asset. So it could be a laptop. If it is in moving from one floor to other, right, the user can able to carry those laptop from one floor to other floor, and it could be an any other high valuable asset. So this is the BLE tag, and BLE tag also will be registered to this BLE mesh. Now, this is in terms of endpoints, right? Now, how we can able to establish the Bluetooth mesh, right? So the Bluetooth to establish that Bluetooth mesh, we need to have the wireless access points. Basically, in the normal term, what we call it as it's a Wi-Fi, right? So in the previous session, I showed you one of the example of the Cisco Wi-Fi, correct? In the Cisco Wi-Fi, we will be having basically different antennas, and one set of antennas will be for 2.4 gigahertz. Okay. Other set will be for a 5 gigahertz. And if we are choosing any of a Wi-Fi 7 technology, then there will be a separate antenna for 6 gigahertz also, right? This is basically for the user connectivity and the internet, and so that networking connectivity. Now, additional to this, we will be having the pair of Bluetooth antennas in every access points. So what exactly this Bluetooth works? So we need to enable the Bluetooth antennas within the access points. If we are enabling the the Bluetooth in all the access points, then what this will be doing is this Bluetooth will talk to each other. Okay, and it will help us to cover complete floor. So I was giving an example, right? Floor 1, 2, 3. So when we have the Bluetooth, the mesh, the complete floor will be covered with this. So now so yeah. Um, so you know there was an technical issues. Okay, and yeah. So I was talking about the BLE, right? What exactly? So here, as I was mentioning, So this is all about the access points. We are utilizing that the Bluetooth antenna here. Okay, that is one thing. Now, so let's take an example. So now that was example for then the BLE tags, correct? So BLE tags will be utilized for the connectivity purpose. Now, what if like you have the lighting, and so how we can able to control the lighting when there is an the large density of occupancy, right? So in that case also we can able to deploy the the sensors which will be having the Bluetooth enabled the antenna within the IoT. Then we can able to connect to that specific access points here. And whenever like someone walks in, right? Let's say this is an complete the facility, the floor, one floor. And if someone walks in and we have the sensor present here. Okay, just a minute. Yeah. So when someone enters the room and we are having some occupancy sensor here, it will sense this and it will communicate to the BMS software, building management software, which will be in the data data center, right? So how the communication will happen? So this will happen like this. So this specific sensor will talk to the earpiece first, because it has to be the communication right now. It will be through the Bluetooth, right? So the communication will establish to the Bluetooth via the access points, and from access points, the data will be transmitted to the BMS software, and BMS software will instruct the lights. Okay, these are all the lights, and these are all the lights will turn on or turn off based on the occupancy one. So everything will be on the Bluetooth technology, and we don't need any the wiring, special wiring required for the IoT sensor. So the main caveat here is the IoT sensor needs to have the Bluetooth one. Okay, and that should be running on the battery power. And the other second the point here is that these batteries usually it will be it will comes around 1 to 2 years of the life basically. And so the Bluetooth technology will not consume that much of energy, right? So only the packets that needs to be flow from the IoT device to the BMS software, that is only the thing it will consume. And apart from that, this IoT will not be sending any of the data. It will be in the sleep mode. Once it detects the motion, then only it will send the required packets. So in that case, so this will the battery life also will be expanded. Okay, that is one of the key factors, right? Okay. Now, this is coming to the penetration and the range. This penetration and the range will be for the facility wide, and this is not for the room level. Okay. It is not for the room level. It is for the facility wide. Now, coming to the third one, that is the long range wide area network. Okay. Now, where, for example, if we have the very big campus, right, where we have the, different IoT sensor, the movement sensors, which will be located in the different parts of the campus, right? And where like we are unable to do the cabling. So basically, the sensor needs to have the power cable and the data cables, right, for the power transmission and the data transmission. So in the very larger campuses where we are not able to do the cabling, right? In that case, we can able to utilize the this wireless technology that will be spreading across for the wider range area. That is one use case. Okay, and the second use case, probably, if we have the smaller, uh, you know, uh, not exactly the smaller one. It is like an let's take an example of the parking space below the underground, where there is like a lot of the moving cars is coming, and where we cannot able to do the cabling works, and the density of the IoT is very much larger in the confined space, right? In that case also we can able to use this long range wide area network. That is also one of the use case. And now coming to the key, the parameters, what it will be using is, so it uses the, sub gigahertz spectrum, that is 195 megahertz. Okay. Or it can able to also use the 868 megahertz frequency to transmit the data. Okay. And the good part about this is, like, when we are utilizing this specific range of frequency, right? So these frequency has the ability to penetrate the walls and the concrete. Uh, okay, it could be a brick wall or a concrete wall. Now, so when we can able to penetrate this, right? So if we have certain infrastructure where we cannot able to puncture that, or else like a deep interior concrete penetration, or else like if we have the glass doors, or very the antique the older walls which we may not be able to penetrate, right? In that case we can able to use this technology where it will seamlessly it will penetrate the building, and it can able to go to the other side of the building for the communication purpose. Okay. And this is one thing. Now, that is for the connectivity of the IoT device, right? And coming to the mechanical use case. So there, for example, if we have the wall, if you want to detect some the water leakage, how do we do that inside the wall? If we are running any pipe, correct, inside the wall. So in that case also, this long range WAN, it will help us to detect this, because it will penetrate through the wall, correct? So when it penetrates through the wall, there will be some absorption and some information we can able to get based out of the frequency which is observed within the wall, right? Based on certain calculation, we can able to get whether there is any leakage or not. So this is also one of the use case, water leakage detection, and also the wall position monitoring, and there are many other use cases are there. Okay, so basically for the multi-mile campuses, this is the wireless technology we will be widely adopting. Okay, yeah. So this is all about the three wireless technologies. Okay, and if you get any of the questions like to explain the wireless topologies, so indoor or else like outdoor, which can able to penetrate the concrete, certain similar to that. Then you have to define the long range wide area network, and also there are other wireless technology, that is BL mesh and threat and matter. So you have to define this, and you have to tell what exactly the protocol is, and what is the key factor, where what is the range and penetration we can able to implement, okay, in your answers. That is one thing. And also one more thing is in the the long range. So I want to mention one OEMs, right? So we have one OEM called Silicon Labs, okay. What is this Silicon Labs? So these are all the one of the very important original equipment manufacturer. They design this long range wide area network. And also we have other one like Nordic Semiconductors, okay. Semiconductors, even they do the research on this long range wide area network on the specific the frequency. And yeah, so this is these are all the OEMs. Yeah, I think we are good here. Okay. Now let's move further. Okay. Again, this is also one of the key important topic to be discussed, right? So now you might have heard about edge computing, right? So in the various if you are attending any latest seminars, right? So you might have heard about edge computing. What exactly is the edge computing? So here, like, we are trying to do the analysis of the ingested data, that is IoT data within the network, or else within the IoT device. Okay, it could be within the network or within the IoT device itself. How we can able to achieve this, and why we need to do this. So let's take an example here, right? Now, for example, we have deployed the IoT sensors in different equipments within the floor. Okay, we might have implemented the thermostats for the heat sensing, and it could be an CO2 for the air quality index, and it could be an movement sensor, and it could be an lux level sensor also, right? For the lighting purpose. So these IoT sensor, what they will be doing is, so they will collect the different parameters, and what they will be doing is they will send these data to the centralized server, correct? It could be an on-premises, or else this can able to send to the cloud also for the analytics. Now here the big problem here is, so these IoT devices, right? So these IoT devices generate so much of data, and few data may not be useful for us. So that is not required for any of the analytics. Could be. So how do we do that? How do we filter out those data which are not really needed for our analytics? So instead of we collecting every single parameters which are generated from the these devices and sending to the cloud, it make no sense, because doing this, one thing what it is happening is we are increasing the cost, correct? Higher the cost. Why? Because if we are generating 1 GB per second based on the different type of the IoT, right? To send this to the cloud, you need to have the bandwidth also, right? The internet connectivity. Correct. So you need to have the bigger bandwidth. Bigger the bandwidth, you have to pay more for the connection part. And it is not only the bandwidth, you need to have the encryption enabled. right? You need to enable the VPN or else direct connect. So let's assume, I am just assuming that we are utilizing the AWS cloud. Okay. To have this encryption, either we need to have the VPN connectivity or direct connectivity. That is what it is. Now, sending the data and the retrieving data from the cloud, it is also the cost. Correct. The more the data you are sending to the AWS cloud, more the amount you have to pay, and also for the processing also it will be an additional cost. And to retrieve the data which we are storing in the AWS cloud, right? Again, that is chargeable, right? The now how we can able to reduce the cost, that is the biggest question here. Instead of we sending all the data, that is the 1 Gbps of data what we have, right? So instead of that, what we can able to do is at a local point inside the network, we can able to process these data. Okay. So how we can able to do is, instead of we sending to the gateway, we will be sending that all the data to the server, which will be in the network. That is on-premises server, which is attached to our network. So all the details from the IoT device will be stored in the on-premises server. In the on-premises server, we can able to do the filtering work. Okay. Once we have done this filtering, so only required data will be sent to the cloud. So like initially it was 1 Gbps, right? After we are doing the filtering and cleaning out the data, it could be hardly 10 MB, or else it could be more than 10 MB, depending upon how many sensors and what the parameters we are trying to send to the cloud. Correct. See the differences. Okay, 1 Gbps to the 10 MB. So this is where we are trying to optimize the solution. Okay. Now, let me clean this out. Okay. Now, what will happen is, now we are processing those data in the local server. Correct. Here, local server. Now, second thing, like the raw telemetry data will be using the older technologies, that could be an Modbus or else Modbus, the backnet, Modbus and the backnet, the TP. Right now, the latest one is the backnet, SE, right? Secure Connect one. Now, this could be also a challenge. Is how do we, resolve this? Instead of you sending the data to the cloud, again, the same pattern. We will be utilizing the, on-premises server to clean the raw telemetry data. Okay. So this is what the local edge computing means. Okay. Now, again, there is another scenario. This is very much latest one. So whatever the IoT device, what I was mentioning, correct? Right now, the IoT devices are smart enough. It will come with a certain set of RAM by default. Okay. And also some small storage. Let's say 8 GB of RAM and 1 GB of storage, and with some CPU. 2-core or 4-core CPU. When this is embedded with the IoT hardware, correct? Now, even though you don't need to send the complete telemetry data, raw telemetry data to the server, which is in the network. So within the IoT device itself, we can able to process these data, and then we can able to send the only required data to the cloud. Okay. So see the difference. So again, this is the latest one. At the edge, at the IoT, the sensor itself, we are computing, we are filtering out the required data, and we are sending that to the cloud. By doing this, we are trying to optimize the cost, transfer cost, and analytical cost in the AWS one. Okay. So basically, what I'm trying to say is like we should know how to do the optimization. Okay, it is very much needed when we are designing a smart building and with the IoT sensors. Okay, just to summarize, whenever it is possible, we have to do the edge computing. We need to filter out the messages or like telemetry data at the edge. Okay, if it is not possible, try to do it in the network level in the on premises, where if we are having any software running in the data center, right, we can able to utilize that software to the filter out, and only the required data needs to be sent to the cloud based on the MQTT, the protocol. Okay, via gateway hub. Okay, let's take in another scenario, right? So now in this scenario, so what we are doing is we are trying to predict the mechanical failure via algorithmic fault detection. So here we are trying to detect the mechanical failure. Okay. So now, so here it is called as FDD, right? Fault detection and diagnostics, which is the FDD one. Okay. So if you compare the legacy one, right? In the legacy one, it's all about rule based. Rule based. When I say rule based, in the mechanical HVAC term, so we will be setting one alert. For example, if the temperature goes above 35 degrees Celsius, trigger an alarm or open the damper or like decrease the temperature. So that certain set of the instruction will be giving. Okay, that is called as rule based. Now, so for example, now what in this specific use case, what we are trying to do is we are not utilizing this rule based, but we are trying to use the edge computing enabled algorithm, that is FDD1. So what it will be doing is it will be running on the microservice on the edge of the gateway for the analysis for the multiple different data stream in the real time. Okay, you need to be understanding what exactly the telemetry data in the real time. Now let's take an example. So this FTD can able to detect and the air which is stuck here. So we have the two input valves. One is outside air, and this is the return air. Okay. Now this the sensor will be calculating the airflow continuously, and it also calculates the mixture of the air temperature. Okay, it could be an outside air plus return air. So it will be keep on monitoring, and so at a certain point, if something goes wrong, right? We have not set any of the manual rules. Manual rules we have not set here. So in this FDD, it is all about the AI, artificial intelligence, which is running on the specific sensor that is on the edge. Okay, that is called the edge computing, right? In the previous the PPT we saw what exactly is that. Okay, so this algorithm which will be running on the specific edge IoT, right here. So it will be keep on monitoring this temperature. Okay, now if it senses, okay, so something is not right as per the historical data, what it will be doing, it will take the necessary action without the manual intervention. It could be an opening the dampers or the closing the dampers. So these kind of actions at the edge itself we can able to process and do it, instead of we sending the data to the centralized processor in the data center, and then giving back the command to this damper to open or close. So this is, we are trying to reduce the latency here, and we are trying to immediately take the mechanical, certain decision at instant. Okay, this is one thing. So yeah, this is one of the use case I was trying to demonstrate how we can able to use the edge computing to take the decision at an edge level instead of we taking the data to the centralized server, processing there and coming back and giving the command to any of the dampers. Correct. That is one thing. Okay. And coming to the the OEM references, so you might have heard about the Schneider Electricals. Correct. Schneider Electricals. So this is one of the the key OEMs who are like pioneer in these kind of building management system. And also we have the Johnson Controls. Okay, even they do this kind of building automation system, especially on the this the edge computing and the backnet and the so on technologies. Okay, this is very much high level. This is one of the scenario, right? Okay, and moving on to the third section. So again, going back to our Cisco spaces references, right? In that, the Cisco space references, we saw how we can able to visualize the complete the smart building. Okay, in that there was a term called rich. Okay, there was a term called rich map. Okay, the 3D rich map. Okay, so this 3D rich map is the simulation of complete smart building in the 3D way. And this software, what it will be doing is, so it will give the number of occupancy in all the rooms. Okay, and it is not only the occupancy it will give, it will also give the one is the temperature of the room, temperature. Okay, and the second thing, it also gives the noise level, and third one is obviously the occupancy, and the fourth one is if we have configured any security, right, access control. This also we can able to see in this specific 3D rich map. And if you see here, there like the color is different, correct? So this is the indication that this specific location, there could be an the increase in the temperature or like a decrease in the air quality, or else number of occupancy are the more than usual or normal occupancy, right? So in that duration, this rich map will give the complete details. So this is also called known as heat maps. Okay, heat maps. Okay, heat map is like we are giving the occupancy and the air quality index in terms of the colorful way, where we can easily identify. If it is in red, then it means that the certain parameter is not good and that needs to be changed. Okay, so this is how the 3D the visualization is what we can able to do it. Okay, right. And this is not only limited to the electrical and Wi-Fi and security. So this can be extended to the mechanical also. If you see here, we are trying to control the system or get the inside of the HVAC system, okay, through this rich map. And also we can able to provide the control from the command center to open or close the specific valve. Okay. This is one thing. Now let's move on to the another important topic. Okay, so let's talk about the attack surface. This is very much important concept. Okay, just give me a minute. Okay, so now let's talk about the attack surface, because any of the IT system, right? It could be an IT OT or any of the system. It is, if it is connecting to an internet or like a wireless device, wired device, so it is susceptible for the attackers, right? If we are not taking care of encryption, or else like if you're not closing any of the open ports or something like that, there will be always an the chances where attackers can able to exploit this advantages in terms of vulnerability. Okay, now in this the smart building, right? In the smart building, usually we will be having the building management system. Okay, and that building management system, usually that will connect to the main data center, and in the data center that will be merged to the IT networks. Right, usually that is the case. Now, the building management system, it is the weakest link, we can say, because that is connected to the IoT devices, the smaller devices, and this will be communicating to this BMS system. The problem here is, so these IoT devices, that is not that much, the security enabled devices, right? That is very much easy to breach. That is one thing. So now let's see how we can able to enhance our the security and the privacy, the consideration in the smart building. Okay, So I was mentioning earlier, right? So integrating the OT, that is the HVAC, the lighting, and it could be an access control, right, with the IT network, and creates a very massive attack surface. Usually, this is the this is how it is. And coming to the three important attack surface, the one is unsecured field buses. Okay, if you see here, uh, let me select this. Yeah, the first attack surface is unsecured field bus. So if you remember, like when we were discussing KNX, right? So in the KNX uses the bus for the communication of the data and the power, right? So if we are not securing these buses, right? If this is running on a older the legacy, that is MSTP, and which operates on an unencrypted manner. Okay, unencrypted. These are all not encrypted. Only the secure connect is the encrypted one. Apart from that, if we are utilizing any of the backnet MS or the TP, it is an the plain text what we are going to send it, right? So let's take an example how this works. So this field devices which is connecting to an thermostat. Let's say we are using thermostat, okay, and this thermostat is connected to the AHU, so air handling unit. And so in the smart buildings, whenever like the occupancy increases, that obviously the temperature goes up and the air quality goes down. To match that, what the thermostat will be doing is it will sense the temperature and it will give the command to the AHU, correct? So now, if we are not encrypting these data, right, that data which is sending from the thermostat to the AHU, so the attackers, what they can able to do is they can able to sniff this data, and they can able to send their own the command to the AHU, and they can able to turn off the AHU remotely. Okay, when this happens, the complete building will have no good air quality, or they can able to do some other various different kind of attacks. Okay, so to avoid this, we always needs to ensure that we use backnet SE or any other, if you are using any other protocols, right? We need to ensure that the field buses are encrypted one, so that the attackers may not be able to inject the bad packets into the system. That is one thing, right? And the second is showdown exposure. So this is, whenever we are trying to configure an IT, especially not IT, especially on the OT side, the, IoT sensors, which may not be using the latest web page protocol, HTTPS. Okay, it might be using the HTTP. Okay, and let's assume we are trying to configure this specific IoT device. Okay, and the admin, what he will do is he will log into the this specific IoT device, and he wanted to do some configuration via remote connection. And this remote connection is open through the HTTP. So obviously the HTTP is not secure, correct? So whenever he is trying to access this specific IoT over the internet, then what will happen is, if some attacker sees this opportunity, then he will be able to sniff into the network and he can able to take down a complete IT/OT infrastructure. Okay. So for how we can able to reduce this, either we need to use the HTTPS, that is secure connection, or we need to use the VPN connection. Okay. And also we need to make sure that we are not opening any unnecessary ports in the network, so that we are not allowing any attackers to come inside our network and do some the attacks, right? That is one thing. Okay. This is the second one. And the last one, the rogue IoT devices. So this is very much important concept. Why? Because let me rub this. Okay. Why this is very much important? So when I say a rogue IoT device, right? This is all about you know additional device which is not related to our network. For example, so initially I was discussing about the BLE mesh, correct? Where we will be using the different access points, that is Wi-Fi points, okay? And the Wi-Fi points will be connecting to each other through the wireless connectivity, and also we are using the BLE antenna, correct, for the IoT. Now, let's say this bad actor, what he will be doing is he will bring his own access point and he will turn on the access point. And the the good part about this access point is it will behave the same way as the access point which is inside our network. It will have the same SSID, and it will it will try to broadcast all the similar parameters which will be broadcasting as similar to our network access point. Okay. Now what sometimes what will happen is whenever you want to do the configuration or like IoT device tries to communicate, it may accidentally connect to this specific access point which has been operating by our attacker, right? So once this connection is successful through the IoT device, then what he can able to do is he can able to come inside our network, and also he can able to log into our the database, and he can able to steal the confidential data, and also he can able to encrypt the complete database with different encryption key, and he can able to ask for an ransom. Okay, this is the kind of vulnerability what we have. So we have to be very much careful. Okay. So we have to make ensure that whatever the devices we are plugging into the device, plugging into the network, those device needs to be authenticated properly, and also the IoT device needs to be added to the specific wireless devices in a caution matter. Okay, we should not be connecting to the network which is not familiar to us. Okay, that is one thing. So these are all the main attack surface when it comes to the building management system, right? Yeah, that is one thing. Let's move on. Okay, so another important topic in the building management system. Okay, now you might have heard about the concept called SD-WAN, right? We have the concept called SD-WAN, SD access. So what are all these? So nowadays we are not relying on the physical, the older way of doing the network security, right? We are evolving now. Everything is on the software defined. Okay, this is software defined wide area network and software defined access. This wide area is network for the a different area connection, and this SD access is for the local devices. Okay, and so to do this we need to have one controller. Okay, main controller, NAC, is what we call network access controller. This is the brain, and you can call it as a centralized command center. Okay, the NAC. In the Cisco we have the ICE, Okay, this is one of the important device in the networking. Right now, so now let's understand how we can able to implement this SD-WAN and SDXs. So the main purpose of implementing this software-defined wide area network or software-defined access is to do the micro segmentation. Okay. So what exactly is the micro segmentation? Let's say we have the different area. Let's consider this is an area number one. Okay. In area number one, we have the multiple the cameras. We have different IoT sensors. Okay, and other set of smart devices. Okay, in the similar way, we have the area number two. This is area two, and even there we will be having the the cameras. We will be having the IoT devices and so on. Right. In the similar way, we will be having different areas. Now, what will happen if all the areas is connecting to the single network as in single subnets? Okay. In that case, if one of the devices get compromised, then attacker can easily able to propagate to other areas also easily. Okay. And this is not a standard design in the smart building. So we need to do the micro segmentation. To do that micro segmentation, we use the two approaches. Okay. The one approach is using the VLANs, that is virtual local area network. Even though the physical connectivity will be remain the same as in single, but virtually we are trying to segregate the devices. Okay, it is like virtually we are dividing the network. For example, these cameras can be configured at an VLAN 100, and access control system can be configured at VLAN 200, and also let's say we have other set of IoT devices that can be configured at an VLAN 300. So this is the virtual segregation, not the physical one. These are all the virtual segregation. What we will be doing is doing. Now, for example, just to take an example, the area one in the camera, which is configured through the VLAN 100, right? Somehow the attacker was able to connect to this specific camera, and the camera was compromised. And when it got compromised, so other devices which is in the same area, that is IoT, it could be an access control, and so he may not be able to breach these devices. Why? Because these devices are in different VLANs. One thing. Okay, so even though these cameras are compromised, it will be very much easy for us to quarantine this specific area. Okay, we can able to disconnect totally this area one cameras from the rest of the physical networks. By this is happening by using the NAC system, that is network access control. And yeah, even in the similar cases, if any of the IoT devices are compromised, then we can able to simply quarantine that segmentation. So these is called as micro segmentations. So it is not a plain single the network we will be having. So we are creating the multiple layers, the virtually multiple layers. Okay, that is one thing, and it will be easy for us to do the quarantine if something the attack happens, and everything is centralized control system and the NAC. So NAC, what it will be doing is, if we wants to do the configuration of any of the IoT devices in the smart building, first this NAC will look into the system, whether the system is legitimate or it is having the proper CA, what is the boot strap, the software, and the integrity of the software, and so on. Everything will be checked by the NAC, and then the NAC will decide whether that needs to be allowed inside the network to be added or not. So the decision will be taken care by the NAC. Okay. Now, simply we cannot able to configure it. These devices also can able to authenticate through the AD. Okay, this is what we can able to utilize the existing active directory for the authentication. Even the device authentication also we can able to do it, and also the user authentication. So this is how it will be, and this is the inside perimeter one. Okay. Now, if the device wants to talk to the cloud, right, via internet, how it can able to communicate? So we cannot allow internet directly connect to our system because internet is not safe. Anybody in the internet can able to push the malicious code, or else they can able to come inside the network and do the attack what they are intended to do. That. How do we secure our network? So we can able to put one firewall, and we can able to define the inbound rules and outbound rules. Okay, and we can also add the white listing of IP address white listing. So this will help us to, the firewall will take the necessary action whether to allow any of the user or the packets to come inside the network or to go out of the network, so that our smart building and the smart devices are secure. It is not susceptible for the attacks. Okay. This is what the microsegmentation, and in the real world scenario also, these are all widely implemented. Okay. So that is where I'm, stressing out and telling in depth how exactly the microsegmentation is. Okay. Now moving on to the second concept. So the previously we saw how we can able to do the microsegmentation, and if something attacks happens, how we can able to safeguard our network. Correct. Now you might have listened the term called zero trust. Okay, and also the edge data privacy. Right. What exactly is this? Now, in any of the network or like IT and OT system, right? The identity, authentication, and the zero trust. So these are the three terms the widely you will hear. So what exactly is this? So no devices is trusted by default. Okay, if we want to add any of the IoT device into the network, it is by default it will not be trusted. So regardless where you are trying to plug in, it is inside the network or outside the network or any of the specific VLANs, or it could be anything. By default, it is not trusted. Okay. So the NAC system, what I was mentioning earlier. So 802.1x, that is the NAC. Okay. Let me write down. So this 802.x, so network access, right? The network must have the encryption, right? The CA. Without that, the NAC, that is network access control device, will not allow the device to connect to the network. Okay. So this is the certificate which the device, that is IoT or any other smart devices, needs to produce to the NAC centralized controller. Once this is produced, then only the IP address will be assigned to this IoT device. Okay. After this, only the IP address will be assigned. And how this NAC device will be knowing what exactly this CA and how to authenticate? There is other integrated service called Radius server. Okay, so Radius server is responsible for authenticating, authorizing, and that kind of authentication and access control, right? So the Radius will be responsible for that. Though this is a separate server. Okay, you just don't worry about this. Okay, you just have to know these terms. Whenever you come across these terms, right, the NAC and the radius, you need to be know if this is related to the IoT or building security one. Okay, that is one thing. And also, this NAC device, what it will be doing is it will do the firmware integrity. So whenever we boot up these IoT devices, correct? So how do we ensure that the software which is installed in that specific IoT device is secured one or not? So there might be an malicious code which is present during the boot also, right? It can directly come into the our network and can cause the damages. How do we ensure that the boot software are authenticated, right? So that is taken care by the NAC devices. Okay. How the NAC will be knowing this specific IoT device, the OS which is which is loaded in that specific IoT is based on the signature. So every manufacturer, whenever they load the software into that IoT device, right? So they will leave one digital signature on the firmware. So whenever so that is the let's say that is specifically digital signature of the manufacturer, and that is like an giving a certificate. So this certificate will be verified through the network access control. If that is matching with the internal network certificates, the series of certificate, then only this will be allowed. That is one thing. If the system NAC system. Yeah, sorry. So if the NAC system, detects any of other signature which is well known as an attacker, like malicious code signature, right? It will immediately stop the onboarding of this IoT device to the network. So this is how the signature will play a key role when we are trying to onboard the device into our network. Okay, that is all about the secure boot. Okay. Only the verified firmware signature will be able to onboard into this. So coming to the famous and the network devices, right? The NAC. So we have the Cisco, we have the Palo Alto, and so on. So these are all the key players which are widely used in the market for the network access control or network. Okay, NAC system, for the NAC system. This is one thing. Okay, so coming to this, the data privacy and the compliance one. Now, you might have, see there will be on camera. Okay, whenever we enter the building, right? And these cameras will be utilized for the movement sensor, as in movement sensor. Okay, and so as per the GDPR, like as per the compliance, there are certain rules where we cannot able to use, or like for example, the facial detection or else any other PIA, right? We should not be saving or utilizing for the internal data processing. So this is one of the key requirements. So even this will be taken care internally, and we need to be ensure that the data integrity, data privacy is maintained when we are designing a system. Okay. Yeah. So this is one thing, and that is the edge privacy. And yeah, if we are detecting any the personal identification PIA, then immediately we just have to discard that. Okay. Once it is only we need to use the metadata, like if we are using any cameras to gather the number of occupancy, right? Once we are taking that and calculating number of number of occupancy, then we have to discard that file immediately. So that is all about the data privacy one. Yeah. So this is how the full stack smart building architecture look like. Okay. So which we already discussed about it, right? Just to brief. So it will be having the 4 layers in the exam. Also, if we are asking you guys to write some smart building architecture, right? What you have to do is you have to define a complete 4 layers, right? The layer one, it is sensors. So in the sensor, we have the high resolution, the time of frame, occupancy, or different type of occupancies what we need to use. Then these data will be moved right by using the connection. That is, it could be an BLE mesh or as the backnet and encrypted other way of communication. It could be a long range wide area network. And then we are moving that to the next level, that is the compute level, where we will be using the different algorithms, or else like we can able to do that in the edge also. Then from there we are moving to the cloud for the analytics, right? And in the top layer, it is all about the security part. So we discussed about the segmentation, we discussed about zero trust policies, right? And this is all about the complete full stack smart building architecture. Okay. Yeah, so this is all about how we can able to design the system. So, however, this is very much high level what I could able to explain. And in the real world scenario, there are like different the parameters we need to consider while we are designing and the implementing. Okay, so for now, as per your syllabus, this should be enough to understand the different type of security, different type of the layers in the smart building and so on. Okay. So now let's move into the very interesting topic, that is the machine learning. Okay. Now let me share my screen. Yeah, great. So in this specific section, what we will be doing is we will learn about the different kind of machine learning models, and also we will study where exactly we can able to implement this machine learning models and what is the use and how we can able to adopt this technology in especially in the electrical and the energy management system. Okay. And we will study different kind of machine learning models what we have, right? So that is one thing. Okay. So I will be back in a minute. Okay, so now we'll start with an introduction to the machine learning in the physical infrastructure, because we are focusing for the infrastructure part, correct? Electrical and IoT part. So for that reason, so we will just focus towards the infrastructure part only for now. Okay. So what is machine learning? So machine learning is where we will be having one model, and we will be giving some data to that, and we will train that model, and we will use that model to do the prediction for the different set of data sets. Okay, that is the machine learning. So it is continuously evolving the model, and every time we are feeding a new set of the data, it will be learning from that data source, and it will make itself smart enough so that if different set of data is fed to that specific model, it can able to analyze and give the output. So in the high level, this is what the machine learning is. Okay. So coming to the introduction part, right? So why this machine learning was very much important, and why it is implemented widely on the IoT energy and the IoT for the analytics one. So if you see the modern infrastructure, right? So we will be having multiple IoT devices, the sensors, IoT and the sensors. Okay. And these IoT and the sensors will be generating the massive amount of the data, right? So every device will be generating the massive amount of data, and these data will be either it will be processed, okay, and we will be taking out the required information out of that. So now, if you consider the legacy models, correct, or legacy approach, where usually it will be a rule-based approach. What we were using earlier, correct? If certain things happens, the certain action needs to be taken. That is mostly on the rule-based one. Now, what is the drawback of that? So the rule-based is kind of the single point of failure, where we may not be able to get the insights what we are expecting, right? The modern the energy grid and the IoT network generate huge volumes, and the rule-based may not be able to get the insights what we are expecting as per the modern scenarios, right? And the complexity has been very much increased. So simple rule, it is not suffice for the complexity, right? How do you do that now? To do that, what we have to implement is we have to implement the AI capability matrices. Okay. So here, when we utilize this AI or like ML based models, if we are feeding the data, so the model can automatically detect what exactly the data set is, and it will process the different data set in the different manner. Okay, it is the intelligent, the models. So coming to this, there are like the 4 different type of approaches what we have. Okay, we also call it as in machine learning models, right? So most important one is the adaptive learning. So this is the most important one. So what is adaptive learning model? The ML model is. So this model specifically, it is keep on evolving continuously from the historical and the real-time data. So let's say this is a machine learning model. Okay. In this machine learning model, so initially we will be feeding certain set of data. Let's assume it is 100 GB of data we will be feeding to train the model, so that the model will be checking what exactly the data, and it will see the trends, and it will see how the data is interconnected and so on. After this, and we will be asking the model to predict certain the analytics based on different set of data. Okay, this could be an 100 MB of data file, which will be fed to the ML and ask for certain actions, right? So this the model will give the output, and this is not only the limited to the 100 GB, and this machine learning will be continuously fed with a multiple set of the data, and also it can be in real time data. And these datas, the quality datas, it always help the machine learning to evolve continuously. It is not the one time learning, it is continuous learning. So that is the one of the machine learning model, that is adaptive learning one. Okay, and the second one is the pattern recognition. So we might be having the data sets with the millions of data points within that data sets, correct? So this specific algorithm, the pattern recognition, what it will be doing is, this algorithm identifies the hidden correlation across the millions of telemetry data points. Okay, so whenever we have the data sets, and these data sets having the correlation, right, in the millions of the telemetry data points. So in that specific use case, we need to use the pattern recognition algorithms. Okay, that is the second one. And coming to the third one, it is the predictive forecast. Okay, in the predictive forecast, so let's say we, how do we, know any of the system will get into an the failure state? Okay, so how we can able to do it? So when we use the machine learning model, which is capable of predictive foresight seeing, right? So based on the historical data, like if we have the demand spikes details for the last 3 years or 5 years, those details, if we are used to train the machine learning model, so what machine learning model will learn is, based on the historical data, it will know where exactly the system might break. Okay, where the system can able to transit to the failure state. Okay, it before it reaches to a certain extent, certain state, this specific model will see the data, and it will give the alert to the user telling that on the certain parameter is reaching the threshold point, we need to take the necessary action. Okay, or else if we are trying to calculate any anomalies, like if someone is trying to breach into the system, or someone trying to steal the power, or like someone trying to hack into the IoT system, right? So these anomaly detection also we can able to predict based on the historical the data which is used for the machine learning for the foresights. Okay, that is the third one. And coming to the fourth one, so automated pipeline. So this is not the physical pipeline I'm talking about. So this is the sequence of decision making, the pipelines. Okay, so here the machine learning has evolved such a way that, so it will be learning on various the patterns, correct? So various patterns, and it will learn what decision has to be taken when. Okay, and good part about this is, the humans don't have to intervene here. The machine learning model can able to take the decision and can able to give the output. And coming to the intelligent loop connection, right? The physical attached asset to the digital strategy. So the previously it was just an the introduction, correct? And now we will be deep dive into the specific ML operations, how the ML is, and how the operations will be technically. So to start with a technical discussion, right? So we will be having, we will be considering in 3 use cases. That is like one is the IoT, and the other one is the energy one, and third one we are trying to do the analytics one, right? Coming to the IoT part. So IoT, so billions of connected devices, right? The sensor, the actuators, the smart meters, the industrial equipments. So they generates the continuous streaming of telemetry data, which we already discussed, right? So this ML enables the edge intelligence and the state classification and the failure prediction and the at an at an device level. Okay, this is what we are trying to achieve when we are utilizing this ML models. Okay, and the similar way that is also for the energy system also here. So the operational environment encompassing the electrical generations, the distributions, the consumption, and ML optimized physical reality prediction and the load demand and so on. So these are all the use cases. Okay, and even and when it comes to the analytics, the designing the digital backbone and AI upgrade analytics from the static dashboard to the active dashboard. Okay, and this is one of the key important, right? The static and the dynamic dashboard. So what is key difference between these two? So static dashboard, it is like for a certain data set, IoT data set. So this will give the status, the static status. So we can able to see the status at an given point of time, but it is not the real time. Okay, and this will not give the real time status and how things is going, and it is not auto refreshed one. Correct. In the dynamic dashboard, it is auto refreshing. So every single seconds or else minutes, based on our the configuration, these dashboards will be changing. Okay. And this, it is not only the value, it will be changing. So we are trying to do the analytics based on the real-time data stream. Real-time data streams. Okay. These are all the use cases. So now let's see how we can able to achieve this. Okay. Now, this is very much key important concept. Okay. Because in the exam also you might get a question asking how the core machine learning engine is developed, or like if we are asking about how the process of training the model and executing and implementing, right? So you have to define these continuous the loop, that is from the step number 1 to step number 6. Okay. So this is a continuous feedback loop. It is not the open-end the process. It is continuous feedback one. To start with, the the raw data collection. So what exactly this raw collection data is? So what we are trying to do is we are trying to gather the continuous telemetry data. Okay. So from where we are collecting the data? From the physical domain. Okay, that is the IoT. And so it could be in sensors also, other smart devices. So these devices will generate the file. It could be in the form of CSV, that is comma separated file, or else tab separated files. Usually the end devices will always send the JSON format one. Okay, it might be in different format, and just to take an example, it could be in JSON format also. And XML, this is one of the format. Okay, these are all the common format. These format, the file will carry the required raw data. Okay, this will gather the continuous telemetry data from the IoT device, that is the physical domain. Okay, that is the first step. And coming to the second step, it is all about the data processing. See, in the data processing, it is where we are cleaning the data. For example, all the data what we have received in the raw data collection, it may not be required for the analytics. Correct? It might be an corrupted one, or it could be anything, any other details also, right? Which may not be useful for us. And in that is one case. In the other case, the whatever the data which we have received from the IoT or the sensors, it may not be sufficient. We may have to enrich that file, correct, by adding some other predictable value to that. So the processing is called as the data cleaning one. Okay. So what this will be doing is, so in the data processing, we are cleaning and we are isolating the valuable signals. Okay, we are just focusing on the specific the data which is needed for the analytics one, right? And also we are converting certain the format. So from the JSON, XML or CSV file, we are converting that to the ORC format and Parquet format. So these two formats are columnar format. Okay, columnar format. So what it will be doing is, so whenever we do the analytics, correct, if we saving the data in the columnar format in the table, it is very much easy for us for the to do the querying. Okay, if we are querying the CSV or JSON format, it it scans complete the table and complete information will be scanned. It is not that much efficient and the resource utilization will be very much higher in that case. So what we are trying to do is, in the data processing, we are converting the raw data into the columnar format. Either it could be an ORC format or Parquet. These two are the very open source, the Apache columnar format, right? So this is process file will be stored in a specific database. If we are considering in the cloud, it could be an S3 bucket. In the S3 bucket, we are saving these data, so that we can able to utilize for the further process. That is the step number 2. And coming to the step number 3, it is all about data selection and the training. So in this step number 3, we are trying to feed the processed data into the selected ML architecture. Okay. So here, let's say we are choosing any of the specific ML model algorithm. Now, this model algorithm, we need to have two kinds of data set. So one is training data set, and other one will be testing data set. Okay. So the training set data set is an large amount of processed data. So this data will be fed to the ML model. Okay. Continuously feeding of this large, and it takes little time for the model to understand what exactly the data is and what is the pattern of the data, and what certain insights it will learn based on the data set. So the training data set is to train the model. Okay. Now next, once this model is trained based on the training set, we need to test that, correct? So what we will be doing is, we will be using the tested data set. So this is the chunk of data set, so which we will be using on the machine learning model to get the result out of it. So initially, for the first iteration, this model can give 50% of accuracy. Okay. Then again, the training will happen with a different data set. Then again, if we are testing that, then it might give some 70% of accuracy, right? And so on. There will be a multiple iterations we need to do, so that the accuracy will be reached for the maximum, that is 90 or 98%, so on. So depending upon our requirement, these changes, right? This is what it is. Now, once we feel like the machine learning, the model is fine, and we can able to deploy that into the production. Okay. Now the second, the fourth step is the validation and the tuning. So this is the trained model, which has been trained on a specific predefined data sets. Correct. In the production, that will not be a case, right? In the production environment, so we expect different variables, different set of datas, and it could be a different pattern within the data sets. Okay, different schemas and so on. So how the machine learning will be able to understand this? So that is the big problem. So for that, we always needs to do the adjusting the hyper parameters and validating the accuracy against the handout data. Okay, so this is the continuous development of the data which are needed. So it is like, again, the validation will be doing, again the tuning of the model will be happening, right? This is the continuous process. After that, once we are satisfied, we can able to deploy that. Okay, in the deployment stage, what we will be doing is, so we will do the pushing this specific AI model to the cloud, or else if we have the on-premises the server, we can able to deploy that in the on-premises, or else if it is a smaller model, we can able to deploy directly on the edge. Okay, so what is edge computing? So we already know about what exactly the edge computing is, right? So we can able to deploy the smaller models in the edge and little bigger models in the cloud, and even we can able to do it on the on-premises one. Now we have pushed the machine learning to the deployment, right? And everything is working fine. As I was like mentioning in the step number 4 for the validation and tuning, right? So again, in the continuous retraining, the similar process will happen. So in this, what we will be doing is, so we will be actively monitoring the deployed models. Okay, actively monitoring the deployed models. So routing the new physical data back to the systems to prevent data drift and so on. So here again, as in the production, we will be getting different kind of data sets, correct, and different kind of schemas and so on. So if we are not training our model, then the accuracy will be going down. Okay, for that reason, we have, it has to be in continuous retraining of the model should be happening. Okay, now, so in the exam, if we are asking about the common ML workflow across all the domains, right? You have to mention starting from the data collection, then we have to move that to the data processing and the feature engineering, and then model selection and the training, and then validation and hyper parameter tuning. Then we have to deploy that either in the cloud, edge, or the on-premises. And also we have to move that to the monitoring and the continuous retraining. Okay. This is how the ML model are trained and deployed, right? Okay. Now let's talk about the different type of algorithms, right? ML algorithms. Okay. Take a minute of break. Okay, so to continue with the type of algorithms, right? We have for the machine learning. Okay, so basically the five important the algorithm is what we have. The first one is supervised learning one. Okay, what is supervised learning? So supervised learning algorithm is used where we have the data set, that is the label data. What exactly is the label data is? So let's say we have the input coming from the IoT, right? So the parameters are well structured, and we have the the parameter, like for example the voltage, the current, and the power factors, and so on. So the values whatever it is coming, it could be 230 volts, it could be some amperes and power factor and so on. So these are all like actually labeled data, and the machine learning model can easily understand what exactly these data are, right? And this is just an example. So in the real world scenario, there will be different type of the data sets what is we'll be using it, right? So coming to the core infrastructure functions, it is used for the regression and the classification tasks. Okay, so it will be very much easy for us to do the classification because all the data is labeled data, correct? And the machine learning, the model, the algorithm can easily understand what the data is, and it can able to do the classification or regression the task more easily. So now when to choose this the model? So as I said before, if we have the labeled data, right? So in that case, it is very much evident that we have to use the supervisor learning one. Okay, that is the first one. And the second one is unsupervised learning. So what is unsupervised? So here in the supervised, we have the data which is labeled, right? In the unsupervised one, if the data is not labeled, okay, in that scenario we have to use the unsupervised learning. So for example, if we are just getting in data like 230 10 amps, so like this, so the model may not be able to understand what exactly these data are, right, if it is not labeled. So in that conditions, we have to use the unsupervised learning algorithm. So wherever we have the clustering operations and the baseline anomaly detection and such cases, we have to use the unsupervised learning, right? Coming back to the third one, that is semi-supervised learning. So in the data set, whatever we have received from the the sensors and the IoT data, if we have the both the labeled as well as unlabeled one data, so it has the mixture of both. In that case, we have to use the semi supervised learning. So when it is used, essential when the manual data labeling is cost prohibitive. Okay, so these are all the main three, the algorithms which is widely used as in base algorithm, right? The supervisor learning, unsupervised, semi-supervised learning, and other like the fourth one is reinforcement learning. So this is other one where we have the no fixed data set. So it is like agent based optimization, right? So dynamic energy dispatch scheduling, or like it is any the dynamic the data set generation that is fed into the system. So when this kind of scenario comes in, then we have to use the reinforcement learning. Okay, that is agent based optimization one, right? And coming to the fifth one, that is the deep learning one. So deep learning, this is like if we are having the vast data set, the gigabits, or it could be in petabytes of data, and it could be an image, or else it could be an video, unstructured data, and so on, where the data has tightly integrated the complex sequence, and in that scenario we have to use the deep learning. So deep learning uses the neural network structures. So it will try to analyze the complete data set, and it can able to give us the insights. So that is the one of the use cases, right? So now we got to know that what are the algorithms we have it for the machine learning. One is supervised learning, unsupervised, semi-supervised, and reinforcement learning, and deep learning. Okay. So try to understand in the depth, okay, what exactly these algorithms, and in the next coming sessions we will be choosing any specific AI models and going deep dive. But still, these are all the baseline algorithms, right? So you need to know the basics, how exactly the machine learning and what are the algorithms. For that purpose, we have introduced these algorithm categories. Okay, right. So now we understood how the AI algorithm is, what kind of data set needs to be fed to that specific AI algorithms, and how the complete data loop for the machine learning works. Right now, let's try to adopt that machine learning to the our energy management system. Right now, let's see how we can able to adopt that machine learning into the current system. So this is how our complete energy system look like, right? So we have the generation stations, we have the transmission lines, we have the distribution, we have the urban load. So this is like consumer side, this is producer side, right? Now, what in your syllabus there is like focused for the adoption of the machine learning towards the uh, energy management, right? So that is where, and here it is not only to the electrical, we have to blend that with the IoT and energy with the analytics one. Okay, this is the basic. Now let's see how the machine learning will help in energy systems. So first, let's see how the machine learning will help in the renewable energy prediction. So in the renewable energy prediction, so we have the forecasting, right? Highly variable, solar and wind generation output, because the sunlight, that is radiations, it is not constant throughout the day, right? It is very highly variable in a similar fashion. So we have the wind. Even wind we cannot able to predict, correct? So wind keeps on changing, and so if we have the historical data of a specific location, okay, for like 10 years or 15 years, so these historical data we can able to fed to the machine learning after cleaning that data. And the machine learning model, what it will be doing is it will understand where exactly the variation is, and it can able to tell on the specific day, this could be an a solar radiation, solar radiation output could be, and this could be an the wind speed on the specific time duration. Okay, that is the prediction for the renewable energy, right? And we'll see certain models which are suitable for this renewable energy in the upcoming classes, right? That is one thing, that is one of the use cases for the renewable energy. And the second use cases is for the fault detection and the diagnosis. Okay, and in the module 3, if you remember, like we were trying to detect the fault in the line. Okay, similar way here we are trying to detect the fault in the line, but here we are utilizing the machine learning model. So here we can able to identify the structural or electrical grid failure before they occur, because uh, so certain details like the age of the structure and age of the circuit breakers, the parameters which are measuring over the time the historical, and if certain breaker has been the failed in the past, why it has been failed. So these kind of data which will be fed to these specific breakers. I mean, these specific machine learning models. These machine learning models will be having these inputs. Then after this, what will happen is, so if certain same situation occurs before the system breaks, it will predict before that, and it will intimate the admins telling that there is a high probability that the system will break. So take the necessary action. So this is what this will be giving, right? ML. So that is the second use case. And coming to the third use case, that is the battery state of charge estimation. For example, if we have battery banks, okay, in the substation or like inside our building, so we can able to use the machine learning to optimize the health and dispatch of the battery storage networks. Okay, so whenever we don't require certain appliance to be used unnecessarily, which is consuming the battery energy, right? The machine learning model can able to give that information telling that it is not necessary, we can able to shut down that. Okay, that is in terms of battery one. And coming to the fourth use case, that is energy threat detection. So we can able to utilize the machine learning model to isolate the anonymous consumption, the patterns, and including the bypass or the theft. If someone directly consuming the electricity or the power from the power transmission line, we can easily can be able to find out, because the machine learning the model will be keep on monitoring the parameters, right? If some parameters is getting variable, then immediately it will flag the details, and then the alert can able to send to the respective person. Okay. Okay, that was the fourth use case. And coming to the fifth use case, where we can able to adopt the ML model for the electricity load forecasting. So based on the historical details or data of the electrical load consumption, we can able to predict what could be the load consumption for next couple of days or the weeks or the next 6 months, because we will be having the historical data, right? So the machine learning model will be keep on analyzing this, and we can leverage that intelligence to do the prediction. That is the fifth use case. And coming to the sixth use case, that is demand response optimization. So dynamically we can able to balance the physical supply and the demand in real time. So that is the beauty of this real time okay, data and the demand response optimization. Okay, that is one thing. Same. Okay, so here we are trying to do the implementation of model, ML model. Same, whatever I had said previous in the previous slide, right? So we can able to implement, strategically in the load forecasting, theft detection, the demand response, renewable prediction, the fault diagnosis, and the battery optimization, and so on. Okay. Now, coming to the other part of important one. So here we got to know that what are the algorithms we can able to use in our electrical and energy management system. Right now, there is a critical task. We need to choose the specific algorithm, machine learning algorithm for the specific task, right? Let's say there are certain use cases which we discussed earlier, right? So for example, let's say fault detection and energy theft. That is what my use case will be. So whenever you want to do that and you want to implement the ML engine, either you have to choose the deep learning. Okay. So deep learning is like, for now, it is the preferred way of doing it. So deep learning, why? Because so fault detection and energy theft will have a very complex relationship between the various data set and parameters, correct? So because of that reason, the deeper learning will help us in the processing the historical sequence data with the real-time data. For that reason, we have to use the deep learning one. Okay, that is one thing. And coming to the second, that is the demand response and energy dispatch. What exactly is this? So demand and energy dispatch. So we have to, at the real time, we have to match the demand as well as the production, right? For that, either we can able to use the supervised learning. Okay, and also we can able to use the unsupervised learning. Okay, and also we can able to use the reinforcement learning, right? The three algorithms we can able to use it. Okay, and when it comes to the load forecasting and the renewable prediction, load forecasting and the renewable prediction, we can able to use three algorithms, that is supervised, unsupervised, and deep learning one. Okay, so why deep learning? Even the load forecasting and renewable prediction, it requires a lot of processing in the background, analysis of the data sets, right? So for that reason, we have to use the deep learning one. And coming to the battery state of change use case, either we can able to use the deep learning or else supervised learning. So why specifically we are emphasizing on this selection of ML model is like, if we are selecting in different models, then we may not be able to get the proper results. Correct. So we have to be very much careful, and we have to be uh, to we have to choose the right machine learning engine for the right use case. Okay. This is all about choosing the ML model. This is one thing. Okay. Now let's deep dive into the specific models. Okay. So we will be, learning about different model type now. Okay, let me open that PPT. Okay, so before we start with an specific ML model, so I want to split these the AI models into three categories. Okay, the one is for the energy system, one is for the energy system, and second one is for the IoT appliances, and third one is for the analytics. Okay, so in the energy management system, so we will be learning nearly three ML models. Okay, one is like so this one, the first one, the LSTM. This is the very famous the model for the energy management system. Okay, that is called also known as the long short term memory for the load forecasting. Okay, that is one thing. And second AI model, what I will be teaching is like XGBoost. XGBoost, specifically this is for the solar. Okay, and coming to the other third one is like isolation forest. Isolation forest. This is for the theft detection. Okay, so we will deep dive in these three models for the energy system. For the IoT, we will be learning different the models. Okay, so coming to the IoT for ML models, that is, hold on, I think, yeah. So we'll start with the random forest. Okay, this is also famous one, random forest. This is pretty much implemented for the predictive maintenance. Okay, and other one we'll talk about the auto encoder for the IoT systems and the tiny ML. And the tiny ML is a very smaller models, tiny ML, and this is where if you want to implement these ML models in the edge, correct, in the edge, where we will be having the smaller IoT devices. So for that reason, we have to use the this tiny models. Okay, and for the analytics, what we'll be doing is so we have the BRAT based NLP feedbacks. That is one thing, and what else will the gradient boost. Okay, so there is other like that is not that much very much important one. So I will be only teaching few ML model for the analytics as well as IoT and energy system also 3 3. So I will be making sure that we will learn the three ML models for the each different system, that is electrical system, IoT, appliance, and the analytics. Okay, so we can. So this will start fresh from the tomorrow with a new model that is LSTM. Okay, for now we'll break it.